All right, so FRQ3 is going to be the third FRQ, and the first one that's non-calculator. So you won't have any calculator for FRQ3, and it will always have a contextual situation. So just depending on, I don't know, what they make up that day. So one thing you'll have to remember is that you figure out the vertical heights based on the context of the problem. So they'll give you enough information to figure that out. And remember, the vertical heights are equally spaced. All right, and then you'll have to figure out the period. So sometimes they give you the frequency, sometimes they give you the period. The period is going to be how long it takes for one cycle. And then sometimes they don't tell you that. They'll tell you that there's 5 rotations in 1 minute. So that's a frequency. So if you figure out the frequency, just do the reciprocal to find the period. All right, you're going to label the beginning of the period. Sometimes you have to extend the graph. So I feel like both the ones we're doing in class, you have to do that for sure, one of them. Oh, maybe just one of them. Anyway, so you need to figure out where time 0 is on your graph. And so sometimes you have to extend it. The horizontal spacing is also equally spaced. And so sometimes you have to find halfway between. Okay, do you guys remember what D stands for? Midline. That's going to be the midline. Yes, good job. All right, do you know what A is? Yes. Technically, A is the absolute value of the amplitude, but to find it, it's always going to be the distance between the midline and the max. And then B is your coefficient of x, and so B is going to be 2 pi divided by the period. And the reason that works is because the period is 2 pi divided by B, and so you can basically just switch those two, and it gives you what to do to find B. All right, and then as long as you set up your ordered pairs correctly, finding C is super easy if you can remember. If you messed up on those, there's a good chance that you're just going to miss C. So hopefully we'll get those right. But if you guys remember, sine looks like this. So it starts at a midline, and then it goes up, and then back to the midline, and then down, and then back to the midline. That is always going to correspond with the point K. So one period of sine starts at K. And so when we find C, we're just going to do the opposite of the t coordinate or the first coordinate at K. All right, where does cosine start? Does it start at a midline or a maximum or a minimum? Cosine starts at a maximum, so cosine looks like that. And that's why whenever it's a cosine curve, C is going to be the opposite of whatever the first coordinate is at F, because F will start a period. Technically, you could also do it at P. P starts a period of cosine also. There's an infinite number of correct answers you have for this one. And I graded some of question 3 over the summer, and I would just type it in my calculator, and if all the points lined up, it was right. So you get your points. So I will get certain points for A, B, C, and D, but they're not the only right points. So just trust that the person grading your paper will get it right. All right, and then when we do C1, it has nothing to do with concavity. And then C2 has everything to do with concavity. And so you're going to describe the concavity and then determine if the rate of change is increasing or decreasing based on the concavity. All right, so here we go. So this one, they give you a nice little diagram, somewhat helpful. But it says that a windshield wiper blade on a car window rotates back and forth. When the wiper blade is farthest to the left or farthest to the right, the measure of the angle formed by the wiper blade and the vertical center is 0.75 radians. At time t equals 0, the wiper blade is farthest to the left. The wiper blade then rotates to the right and passes the center vertical line. At time t equals 1 second, which is a weird time for you to get, well, I guess it's not. At time t equals 1 second, the wiper blade is farthest to the right for the first time, and then the wiper blade rotates left and passes the vertical center line farthest to the left again at t equals 2 seconds. All right, as the wiper blade rotates, the measure of the angle formed by the wiper blade and the vertical center line periodically increases and decreases. So this graph gives you the measure of the angle. All right, a sinusoidal function h measures the angle in radians formed by the wiper blade and the vertical center line of the function. A negative value of h indicates the wiper blade is to the left of the vertical center line, and a positive value of h indicates the wiper blade is to the right of the vertical center line. All right, so what is the smallest angle that we're going to have for this situation? Negative 0.75. So that's going to be my lowest value here. Oh, wait, hold on. I'm going to write it. I'm not going to write on my scratch paper. I'm going to write here. All right, what about the highest? 0.75. And the middle is going to be 0. Now, if it was me, I would just go ahead and fill in my ordered pair, the second coordinate. So this question is a 2-point question. You get 1 point for getting that part, and then 1 point for getting the t coordinate right. All right, so a period is a full cycle of wiping. So if it starts at the left and back to the right and back to the left, that's 1 period. So how long is the period? Yeah, period's 2 seconds. And at time 0, where is the wiper blade? To the left, right? So this is a situation where we technically are going to need to extend this down, and this is where 0 is going to be. And so 1 full period, where is that going to land? If I start there at 0, J. So minimum to minimum will be a full period, or maximum to maximum. Okay, and so halfway between those would be point F. What's that going to be? 1. Now I don't really need this halfway between 0 and 1. It's 1/2 or 0.5. But I do that to know that each time you're increasing by 0.5. So what would it be at G? Good. All right, and we need to get all the way to P. All right, and then fill in your blanks. All right, so that's the process each time. You have to figure out what the period is, then you have to figure out where you are at time 0, and then just affect it to the rest of the graph. Okay, then we're going to go to part B. And part B is always going to say this, well, it changes actually. This one is a sine. You don't have to write this down, but I'm going to write it down so I can see it and talk about it at the same time. But it's a good idea to just, like, in your mind, when you get to part B, but just check. Is it sine or is it cosine? Because that matters when you do the C value. All right, so you get 1 point for A and D, which are the easiest ones to get. So for this graph, what is the midline? Yeah, so that's going to be D. And then what is the distance from the midline to the maximum? Yep, that's going to be A. All right, and then just a reminder, you don't have to show any work on this one, but I'm showing it because I want you guys to remember. B is going to be 2 pi divided by the period. And the period on this one was 2, so B is going to be pi. All right, and then part C, we're going to look back at this graph, and you should be able to see it because your book will open like this one does, so you won't have to be like flipping around. You can just have it open. Remember that a sine curve starts here. And so the C value is going to be how many you shifted to the right. And so because we're shifting to the right, it's a negative. So we just do the opposite of the value at K, which in this case is negative 0.25. All right, any questions on that? So you get 1 point for B and C. So 2 points for part A, 2 points for part B, and then 2 points for part C. So part C, 1.
Was there another way to find C?
I taught it a different way last year, but I don't think I taught it to you guys that way. It's a lot harder the way I used to do it. This is the easiest way to do it. So just think about shifting. And so because originally sine starts in the middle here, it's been shifted however many to this point here. All right, and then part C, this one, the interval will change from problem to problem. This one is going to go from G to J. So we're talking about G to J, right there. In questions, the first one will be on that interval, which is true. And so we're talking about the graph of H, whether that graph is positive or negative at that section, and whether it is increasing or decreasing. So positive and negative, we're looking, is it graphed above or below the axis? So are these values positive or negative? What do you think? Definitely negative. And then this section of the graph, are we increasing or decreasing? Decreasing. So because we're falling. And so to answer that question, do not try to be fancy. Just put the letter. It's a multiple choice question. Just put the letter. All right, and then second part of C, we're going to describe the concavity of the graph in that same section and determine if the rate of change is increasing or decreasing. And we're not going to be fancy. We're going to answer the question. So what is the concavity there? Concave up. So here we go. We're going to quote the problem. After where it says describe the concavity of, we're going to write the graph of H is concave up. And then we're going to skip a few words and we're going to start quoting again. The rate of change of H is increasing. We're not going to try to be fancy and say increasing at an increasing rate. We're just going to say increasing because sometimes it isn't increasing at an increasing rate. At that point in the graph, it actually isn't increasing at an increasing rate. We don't need to know calculus to do this. Just say it's increasing and you're done. Yes?
What if you just put concave up and rate changes increasing?
Yeah, that's okay. You can just put concave up, increasing, honestly. Concave up, comma, increasing. You just have to answer the question. Don't be fancy. But that's the way it is in the past. Now, I don't know if they're going to start grading more difficultly. I don't think they will. We'll just have to see. All right, this one, it's kind of confusing to get what's happening at 0. So we'll read it together. So on this one, The contestants of a popular game show, The Price is Right, take turns spinning a large wheel to see who can get closest to $1 without going over. The pointed indicator is positioned at the center of the wheel, is 8 feet in diameter, and point S is on the outside edge of the wheel. All right, so there we have point S. It tells you in words here that we're 5 feet above the ground, and then we know the diameter is going to be 8, so that's going to come in handy in a second. All right, to ensure the wheel is working properly, the producers of the show perform a series of test spins. The motor of the wheel spins in a counterclockwise direction, completing 2 rotations every second. As the wheel spins at a constant speed, the height of S above the ground periodically increases and decreases. At time t equals 0, S is at the same height as indicated in the pointer. I can't read today, I'm sorry. All right, so the sinusoidal function H models S above, the height of S above the ground in feet. Okay, so here we go. Looking at where S is, do we know the midline? What is it? Yes. All right, and then they tell us also that the diameter is 8. So that means we're going up 4 and we're going down 4 from 5. Very good. Okay, and then it tells us that it spins 2 rotations per second. Is that a period or is that a frequency? That's a frequency. So how many rotations in 1 second is a frequency? So what is the period going to be? 1/2, the reciprocal of that. All right, and this is where I think this question is challenging. So I know it starts at 5, but the wheel is spinning like this. So after it's at the midline, where does it go to next? A minimum. So we technically could make 0G. I never want to do that. I actually think it's the best way to do this problem. I don't like going back in time, but it is acceptable if we make G the midline. So if you guys look, I'm going to post my answers to the question. It will be different, and it's okay because there's an infinite number of ways to do this, but I really think that's probably the smartest way to do this question. So where is that going to make the end of the period be? After P. So this right here is going to be a 1/2. So what's that going to make K? 1/4. What's that going to make J? 1/8. And what's that going to make P? How much are we increasing by each time? How much are we increasing by? 1/8. So we're going up by 1/8 each time. So it's from 0 to 1/8 to 2/8 and then to 3/8. So then that takes us to F. What do you guys think about F? -1/8. Yep. Good job. Now, the math teacher in me doesn't like that, but I really do think that's probably going to be the easiest way for you guys to get those points. I forgot to put my heights in. All right, so don't let fractions worry you. Once you figure out how much you're increasing by, then you can just go up by 1/8. You don't have to reduce any fractions. It can be totally weird. It's fine. All right, are you guys okay? Yes, sir.
Is it better to do fractions or decimals?
I think it's better to do fractions because taking 3 and dividing it by 8 or figuring out what 1/8 is as a fraction on the decimal, unless you just already have that memorized, I think it would be a lot more time consuming. So I would go do fractions and don't worry about reducing. So just 1/8, 2/8, 3/8, 4/8, whatever you need to do. All right, any other questions? Okay, so let's go to part B. Can you guys do A and D without me? Try to do it A and D without me. Figure out the midline and figure out the height from the midline to the max. Right, and then for B, you're going to need to remember that you're going to do 2 pi divided by the period. So our period was a half. How do you divide by half? You multiply by 2. Dividing by half is multiplying by 2 every single time. Taking half is totally different situation. Okay, I didn't point this out, and I should have, because I really want you to look at it every time when you go to do B. This one we're doing cosine. So when we're doing cosine, we look at F, and we do the opposite of this number. So it could be 1/8. Like I said, if you look back at my answer key, I don't have that. I have -3/8, but it's fine. It all works out. All right, y'all good? Okay. And then this one we did change to go from J to K. So when we're deciding for the first part, positive or negative, we're looking at the y values. Are the y values positive or negative? Positive. And then are they increasing or decreasing? Increasing. So that's the answer. You just write A as the answer. All right, what do you guys think about the concavity in that section? Concave up. And the rate of change in that section? Increasing. All right, what questions do you guys have?